So let us start the unit number 4 in computer graphics. Now in the continuation of the preceding lecture, again I am concentrating on line clipping. So how we will clip the line? So far we have discussed regarding the line clipping and we have used the algorithm. Now it is very difficult to examine the endpoints of each line. So there is a method or techniques which we will use so that we can select the particular portion and we will avoid the portion of the line segments which are lying outside the window. So first in this case we will draw the 2D plane because we want to indicate this line whether it is lying inside the window or outside the window. So for that first we will draw the 2D plane, that is the XY plane, and after that we will draw the window, and for drawing the window there are already coordinates, or we can say the window parameters are available. Okay, so with the help of the window parameters first we will draw the window, and after that we will decide which segment is lying inside the window, completely inside the window, completely outside the window, partially inside the window, and partially outside. Okay, so there are number of situations. Accordingly, we can decide. Now, the first condition is this: both endpoints inside the window. Now, here you can see in this slide, both endpoints inside the window. Now, in this example, so here it is understood, no need to clip. So the solution for this is don't clip it because already lying inside the window. So these are the visible line segments. Okay, so these line segments are completely visible because they are lying completely inside the window. And for that, with the help of the algorithm, we will check whether they are lying inside the window or outside the window. Okay, and we have already used one of the inequality, if it is lying inside or outside, or there is a need to clip the portion. Okay, so if any line segment is intersecting to the window, then we can say that there is a need arise to clip the portion which is lying outside or passing through the window edge. So after the intersection point, we will discard the exterior portion. Exterior portion means the line which is lying outside and touching the window edge. Okay, so in case of when both endpoints are inside the window, means no need to clip. Okay, now come to the second situation. So one endpoint inside the window, one outside. So one endpoint in all three line segments, you can check and see here that this is passing, okay, crossing this window side. Again, this line is crossing this window side. Again, this line is crossing this window side, intersecting at a particular window edge. Okay, now here we can see that there is a need to clip the portion. Okay, so we will clip only that portion which is lying outside the window, and we will select the portion from the intersecting points. Okay, so the point which is passing to the window edge, that is called the intersection point, and from that intersection point to the point outside means another end of the line segment, and we will clip that portion, and remaining portion from this intersection point to the point which is lying inside, we can say this is visible portion. Okay, and this will lie inside the window. Similarly, in this case, we will cut or clip this portion from here, and the major portion will lie inside the window. Similarly, in this case also. Okay. Now the third condition is both endpoints outside the window. Now here you can see both endpoints. Now in this case, both endpoints outside. In this case also, both endpoints outside. In this case also. Okay. Here you can see this corner is different of this window, and also this corner is different. Passing this line segment, you can say passing from, you can say, the two intersection points of the window. Okay, this is crossing the window at 2 points, two edges. So now we can say what is the solution, don't know. In this case, the solution is don't know, just like we can say in the case of the truth table. Okay, when both condition we can check in case of the AND gate or the OR gate, in case of the JK flip flop. So there is a one condition comes in which we are unable to take the decision. So similarly, in this case, in the third case, we are unable to take the decision because here both endpoints completely outside. Here both endpoints completely outside, but passing or crossing the two edges of the window. So similarly, in this case, here corner is different, but this line segment passing from the two edges of the window. Okay, so in this case we can say solution, whatever the solution, we don't know. So for this again we will check and divide our line. Okay, first we will do the nomenclature of this. We will put here the name as A, B, and also we can put here C and D. Okay, because these are the intersecting points. Now first we will check, suppose this is A and this is B, this is C and this is D. Then first we will check AB point, okay, and we will compare with the window boundary, okay, means X min and X max, Y min and Y max. So we will compare this portion with the window parameters, okay, and if they are touching, or we are proving the inequality of the given uh, for checking the different points, then we can say that this portion is lying outside or inside. Okay, or we can say completely outside. So for this, here it is written that don't know, or there is no any solution. So for this, we will divide our line into different segments, and we will do the nomenclature at the intersecting points, and after that we will check each portion of the same line segment like A, B, B, C, C, D. Okay, then we will check each portion, and ultimately finally we can say we will get this BC portion will lie inside this, and we will clip by using the algorithm. We will clip the remaining portion, means which is lying outside the window. Okay, so in this case again we will take some decision. Now first case is called the brute force line clipping. What is the brute force? Whenever the lines are passing, touching the window edge, or passing to the window edge, creating some intersection points. Now you can see here, if both endpoints, don't clip lines with both endpoints within the window. Okay, if both endpoints lying inside the window, then we can say no need to clip. So according to the brute force line clipping, how we will perform this? Then first we will check whether both endpoints are completely inside or not of the line segment. If they are completely inside, not touching the window boundary, then no need to clip. Okay. So the first point under the brute force line clipping, no need to clip the lines. Okay. Second, for lines with one endpoint inside the window and one endpoint outside the window. Okay. Now here we can see there are several examples given. Here you can see the red portion. This is the extension of this, and this red portion is outside of the window. Similarly, in this case, just they are indicating this red points here on the window boundary as the intersecting points. Okay, so this is complete line segment here from here. Again, this complete line segment, again, this is complete line segment, but the major portion is lying here inside. In this case also the major portion is lying inside the window, but here the minor portion is lying inside the window. Okay, so such type of, here we can say, lines which are passing to the window edge, then this is called the brute force line clipping, because whether there is a major part or minor portion of the line outside the window, then we can clip those. Okay, then how we will choose and clip those portion which is passing to the window edge. Okay, creating the intersection point on the window edge. Then first we will calculate the intersection point. So in this case, first we will calculate the intersection point. Here you can see, calculate the intersection point. Now using the equation of the line. So here in this case, we will use the equation of the line and then calculate the intersection point. After that, clip from this point out, and after that we will clip the portion which is lying outside. Okay, so the first we will calculate the intersection point, and with the help of the intersection point we will clip the portion which is lying outside. Okay, so in this case we will use the equation of the line. Now you can see, for lines with both endpoints outside. Now the third case. First case completely inside, you have already seen. Second case, partially inside and partially outside. Third case, when it is completely outside. Okay. So in this case, in the third case, you can see here, window tests the line for intersection with all of the window boundaries and clip appropriately. Now in this case, you can say this line, about this line, and also about this line. These lines are completely outside the window because they are neither passing to the window edge and nor touching any window edge. Okay, so these two lines you can see here, these are completely outside. Okay, this line and this line, these are completely outside. And what about these lines? Now you can see these lines and these lines. Here it is passing and creating two intersection point, passing to the two edges of the window. Here this is also, and creating two intersection point. Okay, so we can say that line is lying outside but passing to the two window edges, so creating two intersection point. Okay, so first we will solve these lines. Okay, we will solve this line equation and this line equation with the help of the window boundary, and first we will calculate the intersection point, and then after uh, solving these two equations we will discard the outside portion. Okay, so however calculating the line intersections is computationally expensive. Okay, so to calculate such type of, or to do the such type of calculation, or to find the intersection points, we will do the computation, then it is expensive. Okay, because there is a maybe involvement of the mathematical calculation, and there is an involvement of the multiplication and the division. Okay, so this is called the computationally expensive in case of the whenever we are going to write the program for this. Now, because a scene can contain so many lines, the brute force approach to clip is much too slow. So, whenever there is a number of lines and we are using this algorithm, then we can say the clipping is too slow. Okay, so that also will depend that how many parts or portion or the line segments we are going to test. Okay, so accordingly, first we will calculate or clip the outside portion, and after that, finally we can decide which portion remaining inside the window. Now in this case, you can see only this portion, okay, and this portion. This is not red, means lying inside. So the finally visible portion out of 4 lines, only this, okay, this we can do the nomenclature for this AB. So AB is visible and here CD is visible, okay. So because this is lying inside the window. So first here we will calculate the intersection point, okay, and then we can take the decision, and over this we will solve at the later stage 1 or 2 problems. Then you can do more practice over that and clear all the doubts. Now first here we will emphasize over the Cohen-Sutherland clipping algorithm. So this is called the Cohen-Sutherland line clipping algorithm, okay. So in the preceding we can say slides, we have already done uh, few problems, okay. Then these are based on the or we have already used few methods. So these are based on the Cohen-Sutherland clipping algorithm. So this is called the Cohen-Sutherland clipping algorithm. It is an efficient algorithm to calculate various points, and we can check easily which line segments or portion of the line lying inside the window, outside the window, partially inside and partially outside. Okay. So for taking the decision about the clipping portion which is lying inside or outside, we use the algorithm that is called the Cohen-Sutherland clipping algorithm. Okay. Now you can see here Cohen-Sutherland word division. Okay. So what is done by the Cohen-Sutherland? Here you can see world space is divided into regions. Okay. So Cohen-Sutherland divided this space into 9 regions. Now you can see here, and little bit we have already discussed regarding this. So each region has a unique 4-bit region. So you can see here, this is the image space, this is the image space, okay, completely. So the Cohen-Sutherland divided whole image space into the 9 regions, okay, and this center portion is called the window. So what are the window code, or here we use the 4-bit region code, okay. So there are 9 regions, and for each region we use the 4-bit code, that is called the 4-bit region code, okay. So region codes indicate the position of the regions with respect to the window. Here it indicates the position of the regions with respect to the window. Similarly in this case, so whatever we are going to calculate, we calculate with respect to this window. So this central region is called the window, and for window we decide the 4-bit code as 0000. Okay, and now this is called the 9 regions. Okay, so this image space Cohen-Sutherland divided into 9 regions, and after that this he started to draw the different line segments, and Accordingly, he decides that which portion of the line is lying completely inside the window or completely outside the window or partially inside or outside the window. Okay, so any condition may arise during the solution of the if we are considering various problems over the line clipping. Okay, now here you can see every endpoint is labeled with the appropriate region code. Okay, now you can see here every endpoint is labeled with the appropriate region code. Now you can see here, this is the first we will draw the x-axis and then y-axis. So this is called the 2D plane in which we want to show our image. Okay. So in this case, we will indicate our image. Okay, now you can see here, this is your x-axis and this is your y-axis. Okay, now just consider the window parameters because we are already aware by the window parameters. Then as you are going to draw the graph, so first draw x-axis and y-axis. After that, divide or you can say scale your x-axis and y-axis. Okay, so do the different number of division. Okay, divide your x-axis and y-axis, and then with the help of the window parameters, first you will draw this window. Okay, because we are already aware we have the four window parameters. Then with the help of the window parameters we have the value of wx min, wx maximum, wy minimum, wy maximum. Okay, so first we will consider the value of wx minimum, what is this, and after that we will draw the 90-degree straight line. Okay, so first we will consider what is the value from here. Suppose this is 5. Okay, then from the origin with the help of the scale we will measure 5, and here we will put the intersection point, a point, a dot point, and just put here right angle triangle. Okay, you can use the your triangular shaped so that you can draw the right angle direct perpendicular line. So with the help of this 5 units from the region, just put here and draw the perpendicular line, just straight line here. Okay, perpendicular 90-degree. And again now see the second parameter of your window. Okay, suppose this is 25. Okay, so this is, if this is 25, then from origin count the value of this 25 because you have already divided your scale. Then here just you can say 25. Okay, again draw the a line and exactly at right angle. Okay, 90-degree. Now another window parameter y min. So put again here from the origin count. Suppose this is 5 again. Then draw again this horizontal line but at 90-degree. Here you can see just a straight line. Okay, and again put here, suppose this is 30. Wy max 30 means fourth parameter of your window. Then suppose the from the origin this is 30 units. Then again draw this straight line. Okay, now with the help of this line and this line, it is cutting at 4 places. Okay, at 4 points it will cut. Now put here A, B, C, D like that. Okay, now you can see here your window is ready. Okay, now this here you can see this is the dotted line. Okay, this is the dotted line here. This is called the window. Now with the help of only 4 parameters, you can draw the your window. After that, this is given here. There are various lines. It is given. Okay, P5, P6, P9, P10, P7, P8, P3, P4, this is this. Okay, now everything is given. Now after drawing your window, first x axis, y axis, and then draw the window. After that you can easily decide which one is lying inside or which one is lying outside. Now you can here provide the, or you can change the endpoints with the four region codes. Okay, now this is P5. What about P5? Okay, we are not aware by the coordinates of P5, but you can here just put 0 0 0 0. Why you are putting here 0 0 0 0 to the endpoint of P5? Because it is completely lying inside the window. Similarly, P6, again you can see P6. Okay, you are not aware by the coordinates or the endpoints of P6, but here as per Cohen-Sutherland algorithm, you can put here 0 0 0 0. Okay, 4-bit code. Why? Because this end also lying completely inside the window. Similarly, this is lying completely inside P9. Again, change by 0 0 0 0. Okay. Similarly, you can see any point which is lying completely inside, then replace it by 4 region code as 0000. Similarly, now you can see here is P7. Okay, here is P7. Now you can first go through this. Here is P7, then it is lying 0001. Okay, 0001. So P7 in this region, and in this region you can provide the code. First you remember this image space region codes. Okay, this is divided into 9 regions, so this is 0001. So now you can provide to P3 and P7 because this is lying in this region. Now this became 0001. Similarly, P4, here you can see again, check here 10000. Okay, because this is lying in this region. Okay, in this region, so 100. So you can replace all these um, endpoints by the 4-bit region codes. Okay, now no need to solve these. Okay, here no need to solve these points because this is completely inside. No need to take any decision because you are already aware this is 000 and completely lying inside. But what about these points P9, P10, because this is intersecting the window edge. Okay, then how will you solve this? Okay, then do the ending operation of P9 and P10. Okay, what about the ending operation? You are already aware this 0001 again 0000. Okay, so here you can do the ending. Okay, and then you can apply. So apply the ending operation, and as per the truth table of the AND table, you can take the decision for this line. Okay, then how will you take the decision? Then for that, we will also solve some question at the end of this unit. Okay, lines completely contained within the window boundaries have region code 000. Okay, within the boundaries for both endpoints, so are not clipped. Okay, so here we are already aware 000, so no need to clip here. Okay, because this is lying completely inside the window. Okay, so first we are here ready to completely change into 4-bit region code. The endpoints first we are replacing by their 4-bit region code, and no need to touch this because this is already 0000, means it is lying completely inside. Okay, now you can take decision in this case and other which are passing to the window edges. Okay, now any lines with a common set bit in the region codes of both endpoints can be clipped. Okay, where there is a need arise, to clip the both portion, because one portion is here, you can see one portion is lying inside the window. Here you can see P3, P4 completely outside. Okay, but it is passing through the new regions. Okay, it is not touching your window, but passing through the new regions. Okay, here you can see this is red portion P13, P14. It is completely outside. Okay, completely outside here. Now in this case also outside. Okay. Now here you can see partially inside outside, and here partially inside outside, both there are two intersection points. Okay, but in this case, if you will extend this one, then here P3, P4, here the you can see 0001, this is the 4-bit region code, and again for this is the different region codes. Now we can see which portion we want to clip. Here you can see the AND operation can efficiently check this. Okay, so as we have discussed that where the lines are lying even outside, okay, where there is a need to clip, like in this case, okay, here the clipping is required because this portion is lying inside and remaining portion outside. Here both, here you can see this portion and this portion is lying outside. Okay, so need to clip. Now in these two lines, in this case we will take the decision, okay, with the help of AND operation. So here the point is 0001, here 00010, and we will do the ANDing operation. We will apply the logical AND operation. Okay, and then we can check. So first I am taking your attendance, and after it we will continue. So this is called the Sutherland line clipping algorithm. So in case of the intersection point, we will apply the ANDing operation. Okay. So to clear more about these Cohen Sutherland and Sutherland Hodgman line clipping and polygon clipping algorithm, we will solve some problems. Okay, so that you can understand easily. But after finishing this unit, we will also do some sort of numericals in unit number 4. Okay, now just there is a need only to understand few points so that you can handle the numericals easily. So lines that cannot be identified as completely inside or outside. Okay. So there are also few lines which the user cannot identify whether it is inside or outside. Okay. Then here you can see may or may not cross the window interior. These lines are processed as follows. So there are other conditions for those. Compare an endpoint outside the window to a one. Okay, choose any order in which to consider boundaries, left, right, bottom, top. Okay, here we will consider this order, left, right, bottom, top. Okay, just remember this sequence we will consider in solving the problems. Okay, now, if the remainder here of the line is entirely inside or outside the window, retain it or clip it respectively. Okay, so each portion here we will first check with the help of the left, right, bottom, top. Okay, we will follow this sequence and then we will check each line segments, and after that we will take the decision to clip the portion. Okay, after that we will take the decision which portion we want to clip. Now again, Cohen Sutherland, there are few other points. Compare the remainder of the line against the other window boundaries. Okay, so here we will again testify our line segment with the boundaries, with the window boundaries, and we will continue in this fashion. Okay. So if any line segment is passing to the window boundary or touching, then we will use the ending operation, and after that we will take the decision. For that we will form a table. Okay. In that table we will store the values. Whenever we will do the ending operation, then we will take store the values, and after that we will check which portion we want to clip. Okay. So now I am stopping here, and we will continue the same unit in the computer graphics on the next day. And if any question up till now, now we also have the second class. After 5 minutes, we will continue our second class also. Okay. So if any question, please till now, please tell me. Okay, now I am stopping. If there is no any question, I am stopping here.